Hello everyone and welcome to numerical series of high voltage, and today our numerical problem is a Rogowski coil is to be designed to measure the impulse current 10 kiloampere having a rate of change of current is 10 to the power 11 ampere per second. The current is read by VTVM as a potential drop across the integrated circuit connected to the secondary. Estimate the value of mutual inductance and capacitance to be connected. If the meter reading is to be 10 volt for full scale deflection, resistance has to be selected as 2 into 10 to the power 3 ohm. And the solution is, first of all, impulse current is to be measured, already given in the question 10 kiloampere, so you can write 10 to the power 4 ampere, and the rate of change of current is 10 to the power 11 ampere per second. It is to be appreciated that this rate is mentioned by 1 by 4 cycle of the sinusoidal wave, that is 10 to the power 11 ampere current is obtained by 1 second. 1 ampere current is obtained by 1 upon 10 to the power 10 to the power 11 in 1 second, and 10 to the power 4 ampere current is obtained by 1 upon 10 to the power 11 into 10 to the power 4 in 1 second, so 10 to the power 7. And this is the sinusoidal curve, and this is 1 by 4 of this is t by 4, and time period equal to 4 into 10 to the power minus 4 into 10 to the power minus 7, that is t by 4 equal to 10 to the power minus 7, so t equal to 4 into 10 to the power minus 7, and we know frequency equal to 1 upon t, that is 1 upon 4 into 10 to the power minus 7 cycle per second, and omega equal to 2 pi f, that is 2 into uh, 8 f, we can write 1 by t. The formula f is 1 by t, so 2 pi into 1 upon t. 1 upon t already find, or we can say frequency we have already find 1 upon 4 into 10 to the power minus 7, that is pi by 2 into 10 to the power 7. Now Vm reads 10 volt, that is Vm equal to 10 volt, and we have Vm equal to 1 by Cr into Mi. Value of Vm already given, 1 by Cr into M into I, value already given 10 to the power 4 ampere, that is C upon M upon Cr equal to 10 to the power minus 7, and we know 1 upon Cr equal to scale factor, and integration factor equal to omega upon 10 pi, but M into omega upon 10 pi equal to 10 to the power minus 3, as 1 by Cr is omega upon 10, and you can separate 1 upon Cr. 1 upon Cr is omega upon 10 pi, and M as it is equal to 10 to the power minus 3. Then we can get the value of M, 2 into 10 to the power minus 9 Henry. Now given resistance is 2 into 10 to the power 3 ohm, 1 by Cr equal to omega upon 10 pi. Then put all this value of R omega, we can get the value of C, 10 to the power minus 9